You have access to one of the most brilliant AI models ever created, and you are likely using it right now to do the digital equivalent of tying your shoes.
Yeah, it's wild. We basically treat a massive supercomputer like a cheap pocket calculator.
We do. We reflexively throw our absolute easiest problems at the smartest AI available, and we bleed money in the process without even realizing it. Beat. It is a quiet, expensive trap.
It drives me crazy, honestly.
Yeah.
But today, we're fixing that.
Right. Welcome to today's deep dive. If you are listening to this, you have probably opened your developer dashboard at the end of the month.
Oh, yeah.
You saw the bill for Claude Sonnet 5, and you felt that immediate pit in your stomach.
I know that feeling all too well.
So our mission today is dissecting exactly how to optimize those workflows. You should only pay for premium AI power when you actually need it.
Today is all about building a highly efficient system. I mean, we're going to audit where you're currently wasting money first. Then we'll draw a hard line on what actually needs Sonnet 5. And then, this is my absolute favorite part, we're going to build an automated router.
A system that makes the cost decisions for you in real time.
Exactly. And finally, we'll cover testing and safely migrating your tasks.
But before we can cut costs, we have to slow down. We have to actively observe the moving parts of our daily workflows.
Right. You can't optimize a system if you don't understand its basic mechanics.
Exactly. Breaking down a workflow step by step is crucial.
Think about a standard workflow you run every single day. You gather your research material, you summarize that research, you extract key data points, you write a draft, and finally you review it. Every single one of those steps currently hits the most expensive model.
Pete, I actually have a vulnerable admission to make right here.
Oh, let's hear it.
I still wrestle with model costs myself. All the time. It is so incredibly easy to just, default to the biggest model.
Oh, completely. It feels safer.
It does. You just ignore the bill until it finally hurts.
You are definitely not the only one doing that. I mean, it's human nature to choose the path of least resistance.
Yeah.
That is exactly why we use a specific audit prompt to break that habit. You rate each of your workflow tasks on a strictly defined 1 to 5 scale.
I like the idea of quantifying it, but what are the actual dimensions we are measuring here?
So we measure 3 distinct things for every single task. We rate the raw reasoning required, we rate the potential error risk, and we rate the context requirement.
That context requirement is a really fascinating metric to isolate.
Yeah, it really is.
It essentially measures how much background information the model needs to hold in its working memory to do the job right.
Right, and the results from this structured audit are often highly counterintuitive.
Well, I would assume data extraction is a total no-brainer for the cheap tier. It is just finding a number on a page and pulling it out. That requires basically zero reasoning.
And that is exactly where the trap usually hides. Yeah. Simple data extraction looks incredibly cheap on the surface, but when you rate it on error risk, it scores massively high.
Because of the downstream blast radius?
Precisely.
If it pulls the wrong revenue number, the subsequent financial report is entirely compromised.
Exactly. A bad date or a missing client name breaks everything downstream. So that simple extraction might actually need to stay on Sonnet 5.
Or at the very least, you have to engineer a strict manual validation step.
Right. Now, conversely, basic text summarization feels like a complex premium task. But the audit shows it's an easy switch.
Because it requires low reasoning, and it is very easy for you to spot check.
Exactly.
2-sec silence. Are humans actually good at accurately rating this error risk ourselves? Or do we just suffer from massive cognitive blind spots?
We are honestly quite terrible at evaluating our own risks. We routinely underestimate risk until something completely breaks in production.
Yeah.
That is why this prompt framework is so valuable. It acts as a totally objective mirror for your workflow.
So the prompt forces us to see risks our biases usually hide.
Perfectly said. It takes the emotional guesswork out of the entire equation.
Now that the audit shows us our blind spots, we can move forward. How do we actually draw the line between premium and budget tasks?
Well,
Using Sonnet 5 for absolutely everything is just incredibly wasteful. It is like using a supercomputer as a calculator.
oh, I love that analogy. It's so true.
Routing tasks like this feels a lot like hospital triage. You do not send a guy with a scraped knee to the top neurosurgeon.
Right, you send him to the triage nurse.
Exactly. That frees up the surgeon for the complex traumas. We are essentially building an AI triage nurse.
That is a brilliant way to frame it. We have to identify what truly must stay on the neurosurgeon's table. Complex research is a non-negotiable premium task. Difficult coding definitely stays on the premium tier, and multi-step agent workflows must also stay on Sonnet 5.
Because agent workflows require the model to independently plan, execute, and course correct. That demands high-level autonomous reasoning.
Exactly. Strategic analysis is another one that needs the big brain. The source material gives a really vivid example of this.
What is the example?
Imagine you're asking the AI to compare 5 different competitor reports.
Wow. That is a massive amount of dense, often contradictory information to hold in memory.
It is. You are asking the model to cross-reference conflicting claims. You're asking it to judge the underlying evidence behind those claims.
Right.
And then you want it to recommend actionable new market opportunities.
That requires deep semantic understanding. It has to weigh the relationships across a massive context window.
It also needs to notice when the provided data is simply weak. It has to flag when it cannot responsibly make a clear recommendation.
Yeah.
That kind of nuanced judgment is exactly why you pay for Sonnet 5.
If you move that kind of synthesis to a cheaper model,
The quality will absolutely drop off a cliff. Cheaper models suffer from severe attention dilution. They just lose the thread of the argument.
and then you just end up checking all the original sources again manually, which defeats the entire purpose of automating it in the first place.
Right, you're fixing the weak reasoning yourself. The money you save on the back end is completely wasted by your own time.
So let's contrast that with the scraped knees. What can safely move to the triage nurse models?
You have a lot of great options for the cheaper tier. Categorizing text into predefined labels is a perfect candidate.
Okay.
Formatting raw text into a fixed, predictable structure works beautifully. And basic summarization, as we established, is very safe.
Let's look at formatting into predictable structures, like processing a standard business invoice.
Exactly. You only need a few specific details pulled from the page. You need the company name, the invoice date, and the total amount.
Yeah.
You want to extract it into a valid JSON format, meaning a simple text structure computers read easily.
So instead of returning a messy conversational paragraph, it just returns the raw formatted variables.
Right. The prompt tells the cheaper model exactly what to do. If a field is missing, just return null. Do not try to guess or hallucinate missing values.
This request requires drastically less reasoning than synthesizing competitor reports.
Night and day difference.
Mm-hmm.
The cheaper model is more than capable of this pattern matching, and the result is incredibly easy for you to verify.
Because you just look at the invoice and check the numbers.
Exactly.
So we are looking at a core trio of decision-making criteria here.
Yes. How much raw reasoning is actually needed? How easy is the final output to quickly check? And what is the blast radius of a single mistake?
Is there a danger in defining these tasks too broadly, like assuming all research is automatically complex task?
Oh, there's a massive danger in doing that. Granularity is the absolute key to making this writing work. Researching a simple textbook definition is a very cheap task. Synthesizing an emerging market trend strictly requires Sonnet 5.
Right. The devil is in the details. Nuance dictates the model tier.
You have to look closely at the specific mechanics of the job.
So we have drawn these lines manually now, but doing this by hand for every single task is exhausting.
Yeah, nobody wants to do that.
We need to build an automated traffic controller. We simply do not want to actively think about this every time we execute a workflow.
And that is the real beauty of a dedicated routing system. We shift away from sending absolutely everything to Claude Sonnet 5 by default.
Right.
We create a much smarter automated flow right at the entry point.
It goes from the task to a complexity check. Then it routes to a cheaper model or to Sonnet 5. But wait,
Yeah.
if the router has to read the prompt to decide if it is complex, isn't it basically doing the heavy lifting already? How does it judge complexity without actually solving the problem?
That is the clever part. The router evaluates the instruction's complexity footprint, not the final answer. It is essentially pattern matching the request type.
I see.
We achieve this by using a highly constrained routing prompt on a fast, cheap model.
So the router just looks for trigger words or structural complexity in the prompt itself.
Exactly. The router analyzes the incoming task, that it outputs a tiny, simple piece of code. It just outputs route.cheap or route sonnet.
Right, and it includes one short sentence explaining the reason for the decision.
Which gives you an audit trail. This logic plugs seamlessly into automation tools you might already use to connect your apps, things like NAN or Make.
2-sec silence. Whoa.
What?
Imagine scaling this to millions of automated decisions.
It's mind-blowing.
You are perfectly optimizing brain power and budget in real time, completely hands-off. It is like building a highly efficient digital nervous system for your entire business.
It really is a beautiful thing to watch run. It intelligently evaluates every single request before spending your money. API calls requests your computer makes to the AI become incredibly cheap.
But does adding a router step introduce a new problem? Does it just add a new point of failure or unnecessary latency into the workflow?
There is a very slight delay up front, that is absolutely true. But a microsecond routing prompt is incredibly cheap and lightning fast.
Right.
Because it is not generating a long answer, it saves massive latency and cost on the heavy back-end execution.
A tiny delay up front saves massive time and money on the back end.
Exactly. It is a micro investment that pays off instantly.
So the automated router is built and theoretically ready to go, but flipping the switch blindly across your entire workflow is dangerous.
Extremely dangerous.
We have to test the waters carefully before aggressively moving tasks away from Sonnet 5.
You should never migrate simply because a model is cheaper. That is a guaranteed recipe for broken workflows and massive frustration.
We need a rigorous testing framework before we commit to the new routing.
And the testing framework is actually quite elegant. You take a group of real, typical tasks from your daily workflow. You run the exact same input through Claude Sonnet 5. That becomes response A. And you run it through the cheaper model. That becomes response B.
Then you use a prompt to evaluate them against each other. You are essentially using a large language model as an impartial judge.
Yes. You ask a powerful model to score both responses side by side. You are checking for strict accuracy, completeness, and instruction following.
Okay.
You want to objectively identify any important errors or missing details in the cheaper model's output.
This highlights the hidden, often completely ignored cost of human correction.
This is the single most crucial point of the whole process. The cheaper model might save you a few pennies on API costs per run.
Yeah.
But if it drops one key detail, a human might spend 20 minutes tracking it down.
And 20 minutes of human time completely obliterates fractions of a cent in API savings. You are actually bleeding more money on the deal.
Precisely. If you routinely have to fix missing details or correct formatting, keep the task on Sonnet 5.
Right.
The cheaper model just needs to work flawlessly for one specific job. It does not need to possess the general intelligence to replace Sonnet 5 entirely. It just needs to do its one assigned chore perfectly.
How many tasks should someone realistically test? When do you finally feel confident in the cheaper model's actual baseline reliability?
I strongly advise starting with a small, highly diverse batch. Use maybe 50 to 100 typical daily tasks that represent your actual workload. You need just enough volume to spot repeating systemic patterns of failure.
Test a small, diverse batch until you spot the model's breaking points.
Exactly. Find exactly where it breaks and you map its true limits.
So we have audited, we have routed, and we have tested. Now it is time to safely deploy this system into the wild.
The fun part.
We need to execute this without breaking our daily operations.
The underlying philosophy here is to migrate very slowly. There is no magic, one-size-fits-all traffic split for every single workflow.
The source material shares a really fascinating real-world setup for this migration.
Oh, it is a brilliant example of hybrid model architecture. One user setup used 80% Sonnet 5 for the actual granular execution of tasks,
Okay.
but they used 20% Opus 4.8 strictly for the high-level planning phase.
Because Opus 4.8 excels at overarching strategic foresight. It sets the complex architecture, and Sonnet 5 acts as the highly capable engine executing the steps. And what was the financial result of that specific hybrid split?
They cut their monthly Claude spending by about 50%, and they achieved that massive cost reduction with absolutely no clear drop in final output quality.
That is incredible, but how do we build our own custom deployment plan?
You use a dedicated migration prompt fed with your rigorous test results. This prompt dictates your precise migration priority moving forward.
Right.
It tells you exactly what percentage of traffic to test on the cheaper model first.
It also establishes validation checks and clear automated fallback rules.
Yes. The final elegant operational flow looks like this. The routed task goes to the cheaper model first. The cheaper model generates an output. Then that output hits a strict validation check. Finally, it falls back to Claude Sonnet 5 only if it fails that check.
You are keeping Sonnet 5 as the premium, highly reliable safety net. It is always there to catch the complex edge cases when the triage nurse gets overwhelmed.
It guarantees you never sacrifice final quality for cost.
Beat. What does a good validation check actually look like in practice? How do we automatically check the work before escalating it up to Sonnet 5?
It is usually a very simple programmatic structural check.
Yeah.
For instance, you might run a script to ensure the JSON schema is strictly being followed.
Okay.
Or you write a basic rule that checks that all the absolutely required data fields are present and not empty.
So validation is just a quick automated proofread before calling the heavy hitter.
That is exactly it. A cheap, instant proofread before you pay for an expensive rewrite.
We have covered a massive amount of technical ground today. Let's recap the core philosophy we have been unpacking.
Held good.
Claude Sonnet 5 is an incredibly powerful, premium cognitive tool. But true operational efficiency is using it only where it adds real, irreplaceable value.
Right.
We have to stop paying premium prices for basic budget-level tasks.
It is all about purposefully matching the tool to the specific job. I highly encourage you to look at your own workflows today. Run a quick mental audit of the specific tasks you currently automate. Ask yourself if you are truly optimizing the architecture or just defaulting to the easiest option.
It is so incredibly easy to fall into that default trap. I want to leave you with a final provocative thought today.
Okay.
Let's extend this entire routing idea beyond just artificial intelligence and API overhead. I want you to seriously consider your own biological brain power.
Oh, I really like where this is going.
Think about your daily mental energy as a finite API budget.
Yeah.
How much of your biological energy is spent on cheaper model tasks? How much of your day goes to basic formatting, simple data extraction, or answering repetitive emails?
We all do so much robotic, low-level work every single day without questioning it.
Exactly. What if you rigorously audited your own mental workflow? What if you actively delegated or automated those lower-tier tasks away from yourself?
Wow.
Imagine freeing up your own internal Sonnet 5. You could reserve that premium biological energy purely for deep strategic thinking and complex problem solving.
Building a router for your own brain. That is the ultimate efficiency system right there.
It really is. Thank you for joining us on this deep dive today. We will catch you on the next one.